Hello and welcome to this session where we'll explore an important lighting technology used in many commercial and industrial settings, HID lamps or high-intensity discharge lamps. Whether you're just getting started in the electrical field or just brushing up on lighting systems, this is the place for you. Let's dive in, starting with a big question. Why was this topic created? HID lighting has been used for decades to light up large areas like streets, stadiums, parking lots, and warehouses. Why? Because HID lamps offer something special, a lot of light for a relatively small bulb. They are rugged, long-lasting, and work very well in both hot and cold environments. This topic is here to help you understand the different types of HID lamps, how they work, how they are used, and how to identify and choose them correctly. This knowledge is super useful for anyone working in electrical installation, maintenance, or troubleshooting. Let's break it down. HID stands for High Intensity Discharge. These lamps don't use a regular glowing wire like old incandescent bulbs. Instead, they use a very powerful electrical arc, a spark that jumps between two electrodes inside a small glass tube called an arc tube. Inside that arc tube is a mix of gases and metals like mercury, sodium, or metal halides. When the arc hits those gases, it causes them to glow brightly. That's where the light comes from. This setup makes HID lamps very efficient, especially for lighting up large spaces. But remember, HID lamps can't run on their own. They always need a ballast and sometimes an igniter to start and control the flow of electricity. Now let's look at the four main types of HID lamps. Each one uses different materials in the arc tube, which changes the color, brightness, and efficiency of the lamp. First, let's look at high pressure sodium, or HPS. The arc tube contains mercury and sodium inside a quartz bulb. It produces an orange or amber light. Has very high efficiency, one of the most energy efficient HID lamps. And it's best used in places like parking lots, warehouses, and street lights, places where you don't need perfect color accuracy. Note that high pressure sodium lamps need both a ballast and an igniter, which delivers a very high voltage to start the arc. Some HPS lamps include a reflector inside the bulb to help direct the light more precisely. Also, HPS lamps come in different base types. Mogul base is the most common, and there's the medium base used in lower wattage lamps like 35 watts, 250 watts. And double-ended versions are also available for special fixtures. Next, we have the metal halide, or MH. It has an arc tube that has mercury and various metal halides. It produces bright white light with better color rendering than HPS, and it's best used in places where you need clear white lighting, like car dealerships, sports arenas, gas station canopies, and factories. The one big downside of metal halide lamps is that the color can shift over time, turning slightly pink or blue as the lamp ages. You will see two main types. A probe start, which is the older version. It's slower to start and the color may shift more over time. Then we have the pulse start, which is newer. It starts faster, is more efficient, and better at maintaining brightness over time. There's also a premium version called ceramic metal halide, which offers the best color stability and accuracy. It is used in places like retail stores where colors matters a lot, and is available in both low wattage, which is 35 watts to 150 watts, and now higher wattages, 250 watts to 400 watts. All metal halide lamps need a ballast, and low wattage or pulse start types need an igniter. The base types are usually screw shell. Medium bases for smaller wattages, anything under 175 watts, and mogul bases for higher wattages. Next we have mercury vapor, or MV. Inside it is mercury and argon gas, and it produces a bluish-white color. Its efficiency is lower than that of metal halide or high-pressure sodium lamps, and one of its big downsides is that it has poor color rendering and is not very efficient by today's standards. The use of them is rare today, mostly replaced by better options, but you might still encounter them in older streetlights or signs. They do last a very long time, but they are being phased out due to energy standards. And lastly, we have low pressure sodium. Inside contains sodium plus neon and argon gas. It produces a very pure yellow light, like a yellow highlighter. It is the most efficient HID lamp, even better than high pressure sodium. It has terrible color rendering. Everything that's not yellow looks gray or black. The uses for them are rare, used only where efficiency is more important than how things look. Think of tunnels or perimeter security. If you're wondering which lamp to use, here's a quick breakdown. If you want to go with best efficiency, go with low pressure sodium. If you want the longest life, go with high pressure sodium. If you want the best color, go with metal halide, especially the ceramic metal halide. If you want the lowest cost, go with high pressure sodium. And if you want most light per watt, either go with high pressure sodium or low pressure sodium. Now let's highlight what makes HID lamps so useful. They are very bright from a small bulb, very energy efficient, have a long lifespan, and can be used in hot and cold environments, have very low maintenance, and multiple color options depending on the type. But there are a few drawbacks you should know. The warm-up time. HID lamps don't turn on instantly. It can take up to 2 to 10 minutes for them to reach full brightness. They have a restart delay. If the power goes out, the lamp has to cool down before it can restart. Some can take up to 20 minutes. There is a color shift, especially with metal halide lamps. The color can change over time. They provide poor color quality, especially with high pressure sodium and low pressure sodiums. They are not ideal for low ceilings. Light can be too intense and shadowy. And there's always a UV risk, especially for metal halide lamps. If the arc tube breaks, UV rays can leak out. So open fixtures must be shielded or use safety rated lamps. HID lamps require a ballast to regulate the current. Some also need an igniter to provide high enough voltage pulse to start the light. Here are how long it takes for each lamp type to warm up. For high pressure sodiums, it takes about 3 to 5 minutes to warm up. For pulse start metal halides, it takes about 2 minutes. For probe start metal halides, it takes about 2 to 10 minutes. For multivapor, it takes 5 to 7 minutes. And for low pressure sodium, it takes 7 to 10 minutes. If the power flickers or drops, the lamp will shut off and it won't restart until it cools down. This is called the hot restrike delay. Some special HPS and metal halides lamps have designs that allow for instant restart, using features like double arc tubes. When shopping for HID lamps, you'll come across a code on the bulb or catalog. These codes tell you the shape of the bulb. E or ED means ellipsoidal. BT means bulbous tubular. R means reflector. PAR means parabolic aluminized reflector. Size is usually the number after the letter, shows the diameter in eighth of an inch. For example, a BT56 lamp is 56 divided by 8, which means 7 inches wide. Manufacturers like GE, Sylvania, and Philips publish catalogs with wattage, light output in lumens, color temperature, life expectancy, base types, ordering codes, compatibility with ballasts. Even though names and layout differ between brands, the core information is the same. Manufacturers also publish cross-reference guides, so you can find alternative lamps that match performance, even if you're from a different brand. And lastly, let's review the key points to keep in your toolbox. HID lamps give you high light output, long life, and low energy costs. There are 4 main types: HPS, MH, MV, and LPS. Each type has its strengths and weaknesses, depending on what you need: color, efficiency, or lifespan. Always pair the lamp with a correct ballast and igniter if required. Understand the codes and catalogs to choose the right lamp for the job. Watch out for warm-up delays and UV safety with certain types of HID lamps. And that concludes our lesson on HID lamps. I'll see you in the next video.